Welcome, everybody. How are you guys doing?
Good. How about you?
I'm doing pretty great. Um, Sorry I had to cancel class the other day. I had to run to the hospital because my wife was in labor, and we had a little girl Tuesday.
Congrats!
Congratulations.
Thank you.
Congratulations!
So haven't been getting too much sleep, but it's been fun. It's also a big learning curve as well. Much harder than any math I have learned. Uh, so let me start a new share. Ah, cool. Oops. So I'm using a new setup here outside of the bedroom. So I'm just taking a little bit. Whoops. Sorry. Share screen. iPhone app, AirPlay. Oh, sorry guys. Be back in 5. Okay, I am back. So a few comments. So first, if you didn't do as well as you hoped on the first exam, uh, and you score maybe below 75%, I would like for you to take a retake and also submit corrections just to show that you're ready to take a retake. And I know that one student is planning to do the retake on Monday. So if there's any other students that want to do a retake on Monday, just either email me or message me after class, just to get a kind of sense of it. Is anyone planning to take is anyone planning to, would anyone be interested in taking a retake on Monday if you got below 75? If you got over 75%, I'll just look over your corrections. I haven't had a chance to do that, but I'll look over your corrections and I'll give you some points here and there. But if you do want to take a retake, um, you won't be able to get a full 100, but you'll be able to get a lot of the points back.
Is the grade that we got the grade that's like on like the exam, like exam 1, and then it has like a certain number out of 12? Is that our grade?
Yeah, that's you mean like your grade for the course or?
No, like because when you go into like Math 119 and you click on your work,
Mhm.
and it shows you like exam 1, and then it says blank out of 12.
Mhm.
Is that your score? So if you were to get like less than 75, you would retake it?
Exactly. Yeah. If you got below, maybe below what would 8 out of 12? Not 8 out of 12. Yeah, below 66%.
Okay.
So below 8 out of 12, I would like for you to retake it. And I think everyone can do really great. But if you just missed like a handful of questions and you generally are pretty strong on, like you got more than 8 out of 12, then I'll give you some points back on your corrections. Okay, so on Monday, we're gonna do the retake. Those of you who messaged me, I'll be here, and I'll post this in the class stream as well, but I'll be here not at, this time, let me just double check. I'll be here 3:30 to 3:30 to 4:30 or so. I think that should be enough time to do the retake. But if you need some more time, I'll stick around. So let's say I'll be here 3:30. If you have something going on, you can show up a little bit later as well. But let's aim for Monday retake at 3:30. And it'll be the same format as the exam one.
Could you let Sarah in?
Oh, thank you. Yeah, sorry, I'm on the laptop now, so I don't have all the screens open. Participants. Oh, and if you also don't feel like you're ready for a retake, there's no pressure at all to take it on Monday. I just wanted to coordinate because I got a few students who emailed me. I really want, my goal when you take a retake is that you messed up on the first test, you weren't super prepared, but now you've learned the material, you've spent some time thinking about it, you've asked your classmates, you've seen some more examples, and you feel super confident that you're almost like confident that you're going to get a perfect score. That's really how I want you to approach the retake. I know some students also mentioned to me that they get anxiety during exams and feel like they knew it, but then on the exam they forgot it. And I totally get that. Exams are very stressful. So don't be stressed on the retake if you studied hard and it didn't go as well. I'll give you multiple chances to try to do well, but I will look over your corrections to make sure that you're prepared. That's kind of how I can tell if you know your stuff. I hope that if you have some anxiety during tests, by feeling confident in kind of your knowledge of the material, hopefully that some of that anxiety will go away, and you'll see that you're able to do great. Test taking is really sometimes as much about knowing the material as it is also kind of not psyching yourself out. So, okay. So I got a few students. Those of you who messaged me, also please send me an email, and I'll review your corrections as well and give you some feedback. Okay. So today we're going to continue and start the next portion of the course, which will be based off of questions and material from the statistics and probability course on Khan Academy. And I think they do a pretty nice job. And I'll add in some other content along the way. But I think that they provide some nice like homework assignments and also videos if you want some reinforcement. So the next part of the course is probability. Probability is a very interesting topic, and it's very much related to what we had worked on before, which was counting things, or the study of combinatorics and combinations. So I'm going to give you a little bit of a, well, first let's do a really easy example of probability that I think many of you have seen. So here's an example that I hope you have seen before, and if not, it's no problem as well. But nowadays, especially with Corona, I think there's been a lot of gambling going on. So if you haven't seen it in school, maybe you've seen it or you've heard about it. So Billy, let me change it to smaller here. Billy rolls a fair 6-sided die. What is the probability that he rolls 2 or greater. All right. Anyone want to raise their hand and answer this one? Think about it carefully for a minute. So Billy rolls a die. What is the probability that he rolls 2 or greater? Nice, Quentin. You want to, yeah. So it's 5 out of 6. So Quentin said 5 out of 6. And Quentin, how would you explain why it's 5 out of 6?
Well, the way I thought about it is that rolling 2 or greater is basically just saying rolling not 1.
Mm-hmm.
6 options, only one of them is 1. So the other 5 options are not 1.
Perfect. Exactly. And we're going to use that idea. We used it earlier in counting stuff, like the question with like cars not being together. That was the idea of the complement. And we're going to use that again in probabilities. Yeah, very good. So there's overall 6 possible outcomes. The reason we say it's 5 out of 6, and there's 5 outcomes that satisfy the condition. And I'll highlight the condition. The condition is rolling 2 or greater. So this is the condition. So probability is really just the number of outcomes. The probability of an event is something that you guys probably have seen. It's the number of outcomes that satisfy the conditions of that event. In this case, the event was rolling a dice that's 2 or greater, divided by all possibilities or all possible outcomes. So I'm going to throw in some terminology here that's, if you're about to kind of study probability and statistics, it's important to have seen it. But you know, this is not something to worry too much about. Kind of your general understanding of these things is very, very helpful. So sample space, in this case, is a set of possible outcomes. And we think of a random event as kind of like an experiment where you can have different outcomes. So sample space is the set of all possible outcomes. And we usually, I'm going to write it here. Of all possible outcomes. And we call this like script S. And anytime we talk about probability, we always have this thing, which is going to be the order of S, which I put in absolute value. This means the size. So when you take the absolute value of a set, we call it the order. This is the order, or just the size. It's how many elements of the sample space. For our example, for rolling a die, the sample space is for rolling a die, S is the set of outcomes 1, 2, 3, 4, 5, 6. And we're being very careful here, talking about sample space and kind of writing the different outcomes 1, 2, 3, 4, 5, 6 as a set, and then talking about the size of that set. And I'm just building this up so that when we get to more complicated situations, you'll see that the sample space, the set of possible outcomes, might not just be a list of simple, like six numbers 1 through 6. It might be a list of names. It might be a set of possible like hands that you can draw from a deck. It might be pairs of points. So inside of a set, you can put numbers, but you can put lots of other objects as well. You can even put sets inside of a set as well. So a sample space is just a set of possible outcomes. So an outcome is an individual element of a sample space. So you assume kind of you can only get one outcome at a time. And an event, let me scroll down here. An event, E, is called an event. Is a subset of S. And in our case, the event, so the event described by rolling 2 or greater is just going to be the subset rolling 2, 3, 4, 5, and 6. Okay. This is the event in that case. Okay, and so now we can get to the definition of the probability of an event. And you need to do two things. If you're ever talking about probability, and this is some point where a lot of students get kind of, or not get confused, but miss a key insight. There's two really important things about probability. And it just made up these two things. So we define, this is definition. The probability of event capital E, we call it P of E, is equal to the size of the event set, so how many outcomes there are in the event, and divided by the size of the sample space. Okay, so this is the fanciest explanation of the answer 5, 6 that you've ever seen, rolling a die. Any questions on any part of the definitions that are not clear?
This is kind of just a curiosity. Are sets ordered? Like, is the set 1, 2, 3 the same as the set 3, 2, 1? Or
good. Yeah, Quinn, that's a very good question. They are not ordered. A set is just a collection of objects. So sets, there's a whole like deep theory of like what you can do with the set. The general convention is that sets are not ordered, but you're not supposed to have duplicate items in there. So you wouldn't have a 3, 3 in there. So if there were 2 3s, they would somehow be distinguishable. Oh, so Kieran asked a good question about like what's the distinguishing between absolute value of a set, which we call the order of a set, and the actual set. The absolute value or the order of a set is just a count of how many things are in it. So we don't care what's in it. you know, the set that has apples, oranges, bananas, you know, 6 random fruit would have the same order as the set of outcomes of a die. And so just be careful when you're talking about these things to say, oh yeah, probability of an event is event over the sample space, to make sure to include the bars so that you're talking about the actual quantity of things. Okay, those were good, very good questions. Yeah, set is a collection of unordered items that are distinct unordered items. And then you can start, you know, if you're interested in very mind-bending problems, you can read deeper about set theory, and there's all sorts of strange paradoxes that can occur. And it's a really simple object, it seems like, but it definitely can get complicated very fast. But we're going to kind of go see some nice examples of these objects. Okay, so let's do the next example. I just want to do it as a single page. And hopefully you see that when I mentioned that combinations and the last chapter that we talked about is fundamental to understanding probability, and that's why we spent so much time on it at first. Do you guys see that probability is all it consists of is really counting, but you're just taking a fraction of counting one set divided by counting all possibilities. So let's just do an example that is really relevant to what we did on the exam. So here's a question, and then this will be a little bit of a review. You don't have to, you do not have to simplify this. You can leave it as a combination or factorial. And you don't need to actually give me the number. If you want to plug it into Google and get the number, that would be interesting. But I am more interested in just making sure that you recall this and can apply the idea. So, so here's the question: what is the probability and this is something that's if you've ever watched poker, they calculate these sort of things very quickly and have interesting ways of doing it. Well, actually, nothing that interesting. It's essentially very similar to what we've learned. So, what is the probability of drawing a flush from a set of 52 cards?
What is a flush again?
Oh yes, a flush is all the same suit.
And that's with 5 cards, right?
Oh yes, a flush of a 5-card flush. And then when you finish that one, this will just be, once you know the expression, there's not too much work. And we'll try to get the actual number. The other question is similar. It's what is the probability of drawing a straight of any kind So these are two kind of very fun problems to think about.
I also need to know what a straight is.
Oh, yes, sorry. Yeah, Straight is a set of 5 cards um, that are in order, but they can be any suit. So you can have 3, 4, 5, 6, and remember that the straight can be so 5 cards in order. From let's say aces are high, so you can't start. Ace doesn't start low. So we say you can pick 2, 3, 4 all the way. Then it gets after 10. You want to have a jack, queen, king, ace. So you have to have 5 cards in order, but they could be any suit. Excellent. I got 2 good answers so far for the first one. Let's call it part A and part B. And what we'll try to understand is if once we finish the second one, we'll try to see which one is more rare. Message me also if you're stuck on how to do either A or B. And I'll give you maybe a hint. Okay, so I have a really important question. For part A, what is the sample space? What are outcomes? What are actual outcomes? Anyone want to explain?
But you're asking what the sample space of the question A would be?
Yes, Jeremy.
Well, I would say it would be all the possible sets, well, all the possible flushes that you can get. So from all club spades, hearts, and diamonds.
Excellent. So that would be the event. That would be the numerator. That's exactly right. But what about the denominator? What's like what are we saying like probability of getting it versus doing what? You pretty much got it, but
Would it be the amount of 5-card hands?
exactly. That's right. So the sample space is all 5-card hands you could possibly draw, and the numerator, the events, the subset of that is the hands that are a flush, but they could be any group of 5 that just have the same suit. So any possible flush. So I'm going to do here. This is the size of the set of all possible hands. Maybe I'm going to do as a set. This is not a formal way of describing it, but this is size. How many ways there are to just draw all possible hands, and then the numerator is just all flush draws. Excellent, nice. And Olivia, did you get what did you get for the numerator? Were you able to calculate that one?
Not yet, but I'm not sure how to do that actually.
What about the denominator?
Well, would you use counting in this situation and be like 52 choose 5
Exactly. We can apply the stuff that we learned in the last section to count these sort of weird, sort of complicated objects. So I'm going to write it as the expression here, 52 choose 5. And that's going to be some number. We can, if you're curious, I am curious actually what the overall probability is going to be. And then how about the numerator? Quentin?
Huh?
What did you get for the numerator?
Of the first one,
Mhm.
I got 4 times 13 choose 5 because that's the number of possible hands that have a flush.
Perfect. And I just kind of want to remind us why it's 4 times 13 choose 5?
Yeah, because there's 13 of each suit. So there'd be 13 ways to choose 5 cards, or sorry, there'd be 13 choose 5 ways to choose 5 cards from that suit. And
Mhm.
since there's 4 different suits, you just multiply that by 4.
Perfect. Are there any questions on how we got the numerator and denominator? And hopefully you see that the idea is not really any more complicated than talking about the dice. But the actual counting part, yes, you need to be more careful in how you count things. But the fundamental idea is exactly still the same. Has anyone plugged this into a computer to actually get it? Alex, is it 1.98%?
That's what I got, but it's also possible that I put the numbers in wrong.
Okay. Yeah, if anyone can confirm that, I'll write it down. But
Yeah,
that's
it's 0.0198%. Yeah.
awesome. So 1.98%, which is roughly 2 out of 100. Okay. So all right, I'll give you guys a little bit of time to think about the drawing a straight of any kind. And yeah, message me if you have some ideas. I saw some people message me here. And we didn't quite do that one on the midterm, but it's fun to think about how you can apply counting still and combinations to do that one. Let me see, anybody else? Nice. So Olivia, what do you get as the denominator again? That's a good observation.
I got 52 choose 5 again, just because you're finding the probability out of the whole deck, and so that's how many possible 5 card hands.
Mm-hmm. Exactly. So that's 52 choose 5. And so far we just got one student, I think, who got the numerator. It's a little bit tricky, so I'll give you guys a little bit more time to think about it. Anyone who's kind of working through it, want to share where they're thinking? Because I see some really good ideas in people who are.
I'm kind of working
through it, and I kind of hit a wall.
Uh-huh.
But first, I tried to find the amount of possible configurations of straights there are. So I got
Excellent.
there being like 2 through 6, and that goes through to 10 through like an ace.
2 through 6. And you can also go to, up to, so you can also go through 10, right?
Yeah,
Like
like
1
2
through
through
5.
6,
Oh,
3
ace.
through 7, 4 through 8, all the way up to 10 choose through 8 ace.
Excellent. Perfect.
So that's 9. And then I was trying to find like a way to think about each one in particular. And so I thought for each card it would have to be something like 4 pick 1. And then I raised that to the power of 5 because there's 5 cards. But I don't know,
Nice.
something feels a bit off with that, and I'm not sure exactly what that is.
Quentin, what do you think about Kieran's solution?
I'm confused now because I did the exact same thing, but I forgot that aces and ones weren't the same thing. And somehow that led me to the correct answer.
Wait a second. Did you do aces low as well?
Yes.
Oh,
And that led me to the answer that you said was correct. But aside from that, everything I did was identical to Kieran.
Oh
Yeah.
my gosh, I love Quentin Callahan so
Oh,
much.
I love you too.
Oh, wow.
nice. So I got a few questions about like how do you restrict on making sure that they're in order? And one interesting way that Kieran and Quentin kind of both arrived at is kind of just think of like define an ordered set by kind of labeling the first card. So you can either pick a cards from 2 all the way to 10, which is, I'm always nervous about counting from like actual, including the endpoints, but from 2 to 10, wait a second, from 2 to 10, how many numbers are there?
9.
There's 9, yes. From 1 to 10, there's 10. From 2 to 10, there's 9. And then Kieran and Quentin both correctly pointed out that then you have to make, once you pick where your straight starts, so there's 9 possibilities of starting, so 9 starting points, but then each starting point, you have to choose the 4 different, you have 4 choices of suit for each card, so it would just be 9 times 4 to the 5th.
Why are there only 9 starting points? Can you not like loop around when you do a straight? Does it have to be like, it can't be Jack, Queen, King, Ace, 2?
Oh, okay, yeah. So I didn't specify that. In some games, I think you are allowed to do like aces. No, actually, I'm not sure about looping around. Some games you're allowed to start with an ace. Like you can make ace equal to 1. But I don't think there's games where you can loop around like that. But that's a good point. So we're assuming that you can't loop around. Aces has to, if you end with ace, it's the highest. So the highest straight you can get is the royal straight, 10 Jack, Queen, King, Ace.
Why are we putting it to the power of 5?
Kieran or Quentin, you guys want to?
So for each number you have, right? Say you have the number 2 in your set, you could have it of any of the 4 suits, right? You could have a 2 of hearts, 2 of spades, and that applies to every single thing. So if you have a 2, there's 4 possibilities that could be. And then since you're gonna have a 3, that could also have 4 possibilities. The third card you have, which would be a 4, could also have 4 possibilities. Since you have 5 cards and each of them have 4 possibilities, then it's 4 to the 5th. Does that make sense?
Oh, yeah.
I'm going to do a club here.
Could you repeat that? Do you think? Your explanation for why it's 4
Yeah.
choose 4.
So you have 5 cards, right? And the 10 you had, or sorry, the 9 already tells you like which numbers you have, right? If it's 2, 3, 4, 5, if it's 6, if it's 7, 8, 9, 10, Jack, Queen, but they can still vary on the suit. So if you have a heart or a queen or sorry, a heart or a diamond or whatever, so there's 4 possible suits, and then you have 5 cards. So it's 4 possibilities times 4 possibilities times 4 possibilities times 4 possibilities, which is 4 to the 5th. Does that make sense?
Yeah, thank you.
Okay.
I forgot about the 5.
I'm getting really involved here with these drawings, but very good. Quentin, thank you. And sometimes these kind of probability questions with the mix them with the counting, as you guys just generally know from counting, and you saw me work through some examples and get stuck. They can be tricky, and you might not at first approach it the right way. But definitely with some practice and having seen these types of questions before, you get prepared in that sort of mindset of how to count these things. Okay, very good. So by the way, what is this number? Did anyone calculate it? I'm not sure what it is, but I am curious. And by the way, just let's before anyone announces the number, what do you guys think is more rare? And if you know, you can also vote. Hit yes if you think the flush is more rare. Hit no if you think the straight is more rare. It's kind of interesting to see because they're fairly close. Oh wow, you guys pretty much. Let's see if we can get like 4 more votes and get a tiebreaker. Oh, it just went in the other way. Anyone get this number? 9 times 4 to the 5th over 52 choose 5.
Yeah, I got 0.003546033379.
Awesome. So 0.35%. So 0.35%. So it turns out that the straight is actually more rare. And if you're playing somebody familiar with poker, if you get a straight, it actually beats the flush because it's harder to get. Okay, very good. So that's kind of an example of some of the types of problems we'll see with probability that really connect to the stuff we did with counting. And we're going to keep building on these ideas. And when we get to stats, how many of you have heard of the bell curve? Just and how many of you hit yes if you have heard of the bell curve and no if you haven't? Okay, a few people haven't. Bell curve is kind of like something that shows up in nature and used a lot for test scores to sort of say, okay, well, if I give a test and like the last midterm, for example, was fairly difficult, and I want to curve the grades so that maybe 70% instead of being a C, maybe 70% is actually like a really high score. So I could set a curve and I would make this bell curve shape, and I would say, okay, well, I want some amount of people that are underneath the bell curve to get an A, some amount of people that are underneath the bell curve to get a B, and so forth. And so, believe it or not, but this bell curve shape that we'll study extensively in statistics, it's all built up from these idea of combinations and probability, which when I first learned, I found pretty surprising. And we'll see kind of in more detail how that comes out to be. But the main thing that we'll study in the statistics portion will be understanding the bell curve and how to use it. Okay, let's move forward back to dice. So another interesting probability question. So before we do this, I want to do a quick survey. And everyone, please write in the public chat, what is your favorite board game?
I can't type in the public chat.
Yeah, public
There
chat
is
won't
no
work.
public chat.
Oh, really? Oh, I'm sorry, guys. Ah, okay. Don't know why I had that. Everyone, oh, okay, everyone public and private. Yes. That was gonna be that was the example I was thinking of using. Yeah, everyone just and you can use the same one as somebody else. All right, we got good variety here. Candyland, cool. Monopoly is all skill.
Monopoly. What's wrong with you?
Monopoly is the best. Oh my gosh, chess, I forgot.
I was reading recently that because like AI has gotten so good at chess that they've been doing like people have been studying to find or actually been using AI to try to come up with fun variations of chess. Where like one variation I read was uh, each time for every new game, each player gets like the pawns set up on the second row and seventh row, but the main pieces are just assigned randomly to each player. So it's kind of it creates the situation where you don't. It's not like just people memorizing openings.
I thought that chess variant was designed like 30 years ago.
Oh
Yeah, I think
yes,
Bobby Fischer pioneered that.
Yeah. Chess AI is pretty cool though.
yeah.
Yeah.
So Catan. That's also one of my favorite games. So here's a question, and if you play Catan, you are very familiar with this. Um, uh, what is so? In Catan, you roll 2 dice at a time, and you try to get a number. And similarly, Monopoly, and I think Sorry, and several of the other games as well. Um, so, uh, uh, Billy rolls 2 dice. What is the probability of them and then adding to 8? So I'll give you guys a little bit of time to think about it. And message me if you have no idea where to start. And I'll give you one hint. The whole discussion about sample space, if you can figure out a nice way to visually think of what the samples, first understand what the sample space is, and then visually draw it out, it can make the problem really, really nice to see. But the first thing is, what is the sample space? And I'm gonna, if you're a little bit off, I'm gonna ask kind of how you thought about it. I'm really happy. I'm getting a lot of different ideas, and I'm happy that you guys are like trying to actually attack this problem. You know, not waiting, not just waiting for the answer. Okay. David, you want to explain? Let's see.
So it's like, so there's 6 possibilities
Mm-hmm.
for for the first roll,
Nice.
and then for each roll, I guess you can kind of think of it like a tree. I guess for each one of those rolls, there's also 6 possibilities.
Perfect. Yeah. So there's a sample space. Thanks, David. There's a sample space of 36 different possibilities of what you get on the first roll and what you get on the second roll. These are the outcomes that you can get. So there's 6 here, 6 options here. For the first roll times 6 options. Okay. What would be a good way to visualize these 36 different outcomes? Anyone have an idea?
You could think of it as like a table.
Yeah, exactly. Let's just draw the table here. Maybe the first column, this could be the first row, and the row could represent the second row. So this is 1, 2, 3, 4, 5, and 6. Oops. This is 1, 2, 3. 1, 2, 3, 4, 5, 6. So for example, I'll just draw this like this. If I were to land in here, let's say, that would correspond to rolling a 3 and then rolling a 5. Kalyana, how did you think about counting the numerator? So the events that would, the outcomes that would be considered as being valid for the event adding to 8.
Well, I just kind of went through, it was like 1 through 6 would be 1 and 7, and 2 and 6, and 3 and 5, and 4 and 4. And
Nice.
then just accounted for making sure that the dice would be like, each dice would be getting that. So it would be like 2, except for 4 and 4, because that's like the same thing. If that makes sense.
Yeah, let's highlight them together in the table. So what's the first one that you thought of? And be careful, 7 is not only goes up to 6, so you can't get 7 and 1. That's one of the tricky things.
Yeah, totally forgot about that. Yeah, so you did 2 and 6. Well, yeah, I don't know which way you're going, but.
Oh yeah, we can do it. Yeah. So first roll is 2, second roll would be 6. That would be, I'm just going to highlight here, that would be right, this one. So this, and I'm going to write inside of the box, what it adds up to. And then what else adds up to 8?
4 and 4.
4 and 4. So that would be where? Right here. I'm just going to stick to this. So these add up to 8.
It should just be the staircase. And it should
Exactly.
be going all the way down.
Nice logic. Yeah, just a staircase. 3 and 5. Also 5 and 3. And then also 6 and 2. Well done, guys. All right. So based on this, are these the only, do you guys think these are the only squares that add up to 8? Nice, Olivia. Very good. Yeah. So the answer to this question now is going to be just count the number of orange squares divided by the total number, which is just going to be 5 over 36. Okay. So actually, so based on this and based on this argument, what is the most likely number that you can get when you roll a die? When you roll 2 die, sorry. What do you guys think? What's the number with the highest probability of getting it? Nice, Karen. Yes, it's yeah. Wait, Quentin, where's the robber from? Is that from Catan?
Yeah, that's Catan.
What happens when you get a 7?
The robber.
What, you can steal your like land or something?
Yeah, you put them on someone's tile, and then that tile doesn't produce resources anymore, and you can take one of their resource cards.
Nice. Yeah, I haven't played Catan in a little while. Very good. So yeah, so 7 is the most likely one, and the probability of getting a 7, I'm just going to highlight it here. Let's just do purple. You can do 6 and 1, 5 and 2. And I like this visualization because you can kind of start to see. You don't need to draw to answer this question because you can just kind of list them out and think about pairs that add up to a certain total. You can think of the possible starting numbers. Very similar to how we considered what the straight is, because here, once you know the starting number and you know what it has to add up to, you also know the next number. So yeah, so the probability of rolling a 7, the probability of 2 dice adding to 7 is equal to 6 out of 36, which is equal to 1/6. And what about the probability of 2 dice adding up instead of 7? What if they add up to 5? What would that one be? Careful with the pattern. What's the probability that the 2 dice? Oh, wait, hang on. Yes, add up to 5. Yeah, very good. It is. It's 4 out of 36. That would just be. That would be this one. So 4, 1, 2, 3, and 1, 4. So this is a really handy fact to know if you're ever playing some of these board games, so that you can quickly calculate how likely you are to get what you need. And the trick is to remember that the chance of getting a 7 is really special when you roll 2 die, because for every number that you get on the first die, there's exactly one other number that would get you to that 7. And any number that you get on the first die doesn't mess up your chance of getting the 7. For example, for anything that's less than 7, if you got something too high to begin with, then you can't possibly get the total that you need. And something that's greater than 7, like getting an 8, if you got a 1, you can't get that. And then also, this is interesting as well. You know, the total things go from 2 to 12. So 2, 3, 3, 4, 4, 4, 6, 6, 6, 6, 6, 9, 9, 9, 9, and then 10, 10, 10, 11. Okay. Any questions on this table? And kind of how we're applying, we saw 2 different ideas, 2 different examples of using this idea of the sample space to answer a question about probability. And probability questions can get pretty complicated pretty quickly, surprisingly. Because calculating different possibilities and situations, because counting in general can be tricky. So Kieran asked a good question. Are there any good visual examples for 3 or more die? What do you guys think? That's a very good open-ended question.
3D table.
What's that?
3D table.
Yeah, 3D. So a 3D table for 3 die is excellent. For 4 die,
40 table.
40 table.
yeah, you would need a 4D table, which is doable. You just have to have multiple cubes for depending on what you get on the first. Like, if you get a roll of 1, you have a cube. If you roll a 2, you have another cube who represents the remaining 3. So it's kind of like a hypercube. Okay, so let me ask you now one last question about this, where I'm going to combine different ideas, and you can think about this sample space in an interesting way. So let me write it over here. And this will be our last example. What is the probability of rolling? So when I say rolling, I mean rolling 2 dice that add up to 9, or the second die is greater than 5. I'm just going to copy and paste here. Oops. Ah, shoot. Oh, sorry, greater than, my bad, greater than or equal to 5. Go for it, Alex.
Okay, so I looked at the row that had 9 and I saw that there were 4.
Perfect.
There's 4 for 9, and then I looked at the row in the second column that has both 5 and 6, because that's like the greater numbers. So I did 5 and like either counted, or I just did 2 times 6 since I knew it was a grid of 6. But then I had to subtract 2 because we can't count the 9 twice.
Excellent.
Those are in that grid.
Very good. So, and then, yeah, so let me put this together. So, or we saw earlier is either option or both of them is allowed. So if I color this maybe in, let's say, pink, that would be kind of these guys as well. So this doesn't look like the Venn diagrams, but hopefully you see it's exactly like, the concept is exactly the same Venn diagram concept, where the 2 9s in the purple rectangle are like the overlap. And Alex did a great job of kind of saying, wait, we don't want to just do 4 out of 36 plus 12 out of 36 or 2 out of 6. We also want to subtract the 2 9s that are the 2 outcomes that are part of both event. So I'm going to write down here what it is. This is 4 out of 36 plus, I'm going to just do it, 12 out of 36 minus 2 over 36. And this is going to bring us to a formula that we had discussed a little bit when we were doing the combination questions. And the formula is the following: the probability of the union of 2 events. And remember, union, I'm not sure if we talked about it that much, and I'll maybe talk about it more next time. Union is that U symbol, and it has to do with event A, or set A or set B. So it's kind of like when you have the Venn diagram, it's the entire collection of things. So it's either one or the plus the overlap. So the probability of the union of event A or B is the probability of each one separately added together, but that overcounts something. The one that's in both of them gets overcounted 1 time. So you want to subtract what event is in both of them. Okay. And so in this example, if you add them all up, you look at there's 2 green squares outside, and there's overall 12 squares in the purple rectangle, and you don't want to overcount them. You don't want to add the other two green because they're already in there. So this would be overall 14 over 36.
What is the upside down union called again?
Yes, this one is union. This one is easy to remember, and the way I would always remember it is just by not knowing it's not the union. The upside down U is the other thing. It's called the intersection. Union is like the two things that are, the two sets all together. Intersection is the overlap. So this is A union B is the whole thing. And the overlap is this thing. That's the overlap. And the union is kind of the whole thing. Okay. All right, guys, that's all for today. I will post some work on Khan Academy that's based on kind of intro to probability. Some of the problems that you might see there will be kind of similar to like questions that I asked today where you have the tools to answer them, but I'll leave it to you to try to figure out how to think about the sample space and how to use counting to figure out both the numerator and the denominator. And if you have any questions, you're welcome to email me and also take a look at some of the videos as well. But this should be a really good foundation to move forward with probability. In fact, I think most of the questions you'll find will be on the homework will be pretty easy. And also those of you who came late, I'm planning to do a, yes, so the homework will now be the Khan Academy stuff. I'm just gonna check that you did it. And I will ask, I will also like to see your notes, just kind of, yeah, I'd like to see you write down your notes and also submit your answers so I can track how you're doing, but also I can see your work so that you're not just like, I'm going to make all the problems the same so you guys can work together and we can go through them together as a class. But I don't just want you like clicking.
Sorry, what notes?
When you do the homework, just make sure you're doing it like as if you're doing a homework from the book.
Oh, for the Khan Academy.
For the Khan Academy stuff. You don't have to, we will do the other, so I haven't posted the Khan Academy stuff yet. I will post that by tomorrow, but I'm going to try to get it posted today. It's going to be like a few exercise sections, and it'll probably be like 4 questions per section or so. And you're welcome to work on it together, but I will ask you that you submit the answers on Khan Academy, like just like actually go through all the choices and see which ones you miss, and then you can fix them later. And also upload upload your work. And then
So on paper, do you want us to like write the question down and then do the work and write the answer down, all that kind of stuff as well, or just like you want to turn in our scratch paper?
Yeah, I mean, write it kind of neatly, but if it's a really easy question, like the one, if it's like the first one I asked, like about like how many ways are there that more than 2 or something, it was 5 out of 6, you can just write the answer like that. It's something really easy. But if it's something like where you have to kind of come up with an argument, I would like to see you like show your work and explain your argument there.
All right, cool. Thank you.
And so I will make a Google assignment so that you can turn in with the Khan Academy. And again, I'll try not to assign too much because I know you guys have other work going on, and I know you've put already a lot of work into combinations. So do as much as you can. If I assign too much, you're behind, just let me know. You're welcome to turn in a little bit later, but I'll try to keep it at a reasonable amount. All right, guys, have a wonderful weekend, and I will see some of you on Monday for the retake. If you kind of got below 8 out of 12 or below, you're welcome to take a retake if you submitted your corrections. And please remind me as well that you plan to do a retake. I will look over your corrections and give you some feedback. All right, guys, have a wonderful weekend. I'll see you on Tuesday, and some of you on Monday.
Bye.
Thank you.
Thank you, Daniel.
Bye.
Thank
Thank
you.
you.
Thank you.
That's on the baby.
Thank you guys.
Daniel, just a quick question. So do you want us to send an email still for the?
Wait, what was that? I didn't catch it.
Do you want us to still send you an email if we want to take the retake?
Yes.
Okay.
This way, I'll just put retake in the subject, and I'll just this way I want to go over your corrections. Make sure that you kind of are prepared for the retake.
Okay. All right. Thank you. Congrats on the baby, by the way.
Thanks, Jeremy. Bye.